Hello everyone, good afternoon. At the Swiss TPH, we work on two main strategies towards the control of schistosomiasis. On the one side, we have some groups working on education, prevention, and infrastructure improvement. On the other side, where I work, is drug development. So how can we improve the control of schistosomiasis, considering there is only one drug available and has some critical limitations? By the end of my PhD, we will hopefully identify a new molecule with the potential to become a new therapeutic option. But what is actually schistosomiasis? Schistosomiasis is a human parasitic disease that is transmitted to humans by contact with contaminated water bodies. It affects 250 million people in tropical countries, and most of them are children. It causes a chronic infection, which in children produces mental and growth development delay. This produces a severe contribution to the vicious cycle of poverty and disease in neglected communities. Fortunately, we have a treatment for this disease. It's praziquantel. Praziquantel is a very safe and very effective drug, but has some critical limitations. First of all, considering that our population are the children mostly, the drugs are very big and very, very bitter. This is not very convenient for children. Secondly, and very important, the drug is not active against all the stages of the parasite. This means when we treat the population, a certain part of it will not get cured after the treatment. Third of all, this drug has been developed in the 70s. This means 40 years of uninterrupted use. We have a very high risk of resistance because this drug has been used without interruption and also in the last time even as monotherapy. So we need new drugs and we need them now. We might have a solution to this issue. Oxamniquin derivatives. Oxamniquin is a drug that has also been developed in the past and has been used in humans, but has fallen into disuse because of two main reasons. It developed fast resistance and also was not active against all the species causing schistosomiasis. Together with collaborators, we developed 3 new molecules with the potential to become new drugs. We tested them in vivo, in vitro, and also we did some toxicology studies in mammalian cells, and all this passed the first stage. My work on this PhD is to identify which of these 3 molecules better fits the condition to become a new therapeutic option. This means we need a drug that is active against all the species causing schistosomiasis, against all the stages of parasite, and also a drug that is active against all the stages of parasite, and also in resistant strains. Well, with the lead candidate we detect after the three candidates, we will then focus on pharmacokinetic studies in rats or mice animals to then detect which is the best candidate. So at the Swiss TPH, we are very aware about the challenges to control schistosomiasis. That's why we focus our attention on 2 main strategies, prevention and drug development. So this was my talk. Thank you very much for your attention.